Welcome everyone to this short update. So probably best to press some button. I wanted to present you some more working samples, otherwise might get a little bit too depressive with non-working cross-compiled Firefox stuff, but it's mostly a Spark and big-endian and MIPS issue. Because it didn't work on the SJ Octane, MIPS32, Firefox crashing, and yeah, built with debug symbols 2.5 GB. Probably need some more memory and swap to load that or load that on a cross debugger. But this is also MIPS, not yet shown here that much on this channel. Imagination tag CI20 with some Chinese, what exactly was it? Engine tag or something. Let me just. So this would be Ingenic and some freaking JZ 4780 core of, they call this X-burst CPU stuff. Full disclosure, not a paid advertisement, but Imagination Tech senses some 5 or 6, 7 years ago when this was new, this creative CI20 board for Raspberry Pi competition. So performance-wise, so this is latest Firefox as per usual, cross-compiled yesterday. And don't mind the resolution, this is just some, doesn't really matter too much, but just to give you here some performance stuff, and probably I should provide some real benchmarks. So speed-wise, it's no surprise, I'm not a speed devil, but hey, it's not crashing so much to that. So this is certainly, you don't get this at other distributions. A MIPS little-endian. So what the difference is also, so compared to the Octane, Octane is 64 bits. This is only, well, 15 years later. Only 32-bit because embedded. And where was the help? Should it? Oh, we have menus, or is it menus? Oh, menus that scroll amazing stuff with this resolution. So this is, yeah, it's not, although this is Power VR because, yay, Power VR. Also, yeah, reverse engineering this someday, right? So 8102, and in contrast to Spark and MIPS64 Octane, not crashing, but yeah, it's not a rocket science. Oops, yeah, even graphic stuff. Yeah, Power VR graphic of closed stuff, and yeah, so Navic. So you, in contrast to other stuff like Pine Phone, previous video, or even the G5, Apple G5, you probably don't want to use this to browse the internet. I mean, each click here is a pain, and this is fully optimized, right? So this is, you might be able to squeeze a teeny little bit more out of this, but it doesn't fix this kind of performance. Let's see, yeah, scrolling, but scrolling is already, okay, well, this works somewhat, but yeah, re-rendering this stuff, it's like, yeah, we are waiting 2 Mississippi seconds, and yeah, caching and stuff, in contrast to what is your modern browsing experience. And if you get single board PCB stuff of, yeah, probably, also this probably gives us some indication, although this is running on dual 1.2 gigahertz, it's and not the super state-of-the-art fastest, it's probably faster than the SJ Octane. So browsing on the SJ Octane will probably be a less than, oh, this was on a website that is long, but yeah, each click here is a pain. Also, it would be really interesting to see, to get this working on the Octane just for educational purposes eventually, someday, maybe sometime soon. But yeah, also you don't really want to use it like this because, all right, we can even browse hardware we have here. Yeah, but basically, I mean, this is even local area network, right? So this is LAN. I know this server is, let me think, this is going, actually this is going to the data center, but at least as far as I remember, that's actually in the data center, but yeah, you don't want to even but yeah, to be fair, it is 7 years old, so this board, and when it came out, it wasn't the latest and greatest state of the art. So much to, I also slightly wonder what Imagination was thinking to get this to the market when they purchased this MIPS. So this core here is this one, this JZ 47080 2012, just so only 8 years old, and certainly 12 years or so, with 15 years, 14 years, 15 years younger than the Octane. 40 nanometer dual, so it's even freaking dual core. MIPS32 revision 2 single instruction multiple data, 1.2 gigahertz, Power VR. And also here's a brief, so what you often don't find that much is a pipeline and stuff, because yeah, Asians, like, yeah, new Asian manufacturers, like, yeah, YOLO, whatever, you get something and maybe it works a little bit. So no surprise therefore. This is some Chinese, yeah, founded in 2005. So this is 7 years in their design stuff. So, or actually maybe the first expert. So this is maybe a 2005 design with yeah, 180 nanometer too. Maybe only die shrink and some design improvements, and similar. Where do we have 16K larger, 32K each? So yeah, larger caches, L2. The first didn't have L2 cache maybe. So yeah, so this is also when you get today RISC-V silicon. It's of course all the pipeline stuff similar to this. New companies need to design and learn, develop and research. The only thing they write here is A9, was it 9 pipe line? And yes, this is a block diagram, peripherals, the 2x burst, 1.2 gigahertz, of course, that as you see are not the super fastest. Some Power VR, that, yeah, reverse engineering, some peripherals, HDMI, and yeah, so 9-stage, and also dual X burst core 9-stage pipeline stable on 1.2 gigahertz. I mean, the wording is also already, even for my German English, a little bit funny. You don't really learn here more. Like, this is also the problem with like no-name stuff you don't get, but it doesn't really matter. It's slow, whatever. Compared this to the previous video PinePhone, we had there this all-winner A64. That is a Cortex, which also I will actually get out and test next, just to see, but I think it was significantly better. Certainly not daily usable on a desktop, but yeah. Cortex A53, so this is also a 2012 design actually, so much to this all-winner stuff. Yeah, a little bit aging. It also explains why it's not the top of the line performance. 8-stage, so this is 8-stage pipeline. Two-way superscalar, also here ARM certainly at that time some 20 or at least 2000, yeah, over 20 years. At that time, CPU design experience, DSP Neon FPV4 floating point unit per core hardware. Yeah, it has even hardware virtualization support. Amazing stuff. So yes, it has a 1-stage shorter pipeline that certainly doesn't give much different performance. Maybe some less than 10%. Two-way superscalar, also in-order execution on the all-winner A64 that is in the PinePhone. So both not performance rockets, but nonetheless, it would be interesting to know more precisely what is the huge difference. Although this is 64-bit, and from that point, at least on the ARM side, as we've seen in my previous instructions and architecture videos, a little bit better instructions and architecture with less historic ARM conditional execution bits on each instruction, and twice the amount of registers for that. Anyway, I just wanted to present this update also for you to see what kind of performance you get. Otherwise people always get something, or Raspberry Pi, and yeah, certainly Raspberry Pi a tiny little bit faster like this, especially the very latest one, but nonetheless, yeah, I mean, at least the highlights are pretty okay. Actually, even the highlights are not the most snappy. Yeah, so performance, yeah, but also this is everything, right? Memory and cache, and who knows what. I certainly don't have time and stuff to research all the latencies in L1, L2 cache and so on, but one day I will for sure on some of those devices. Maybe we start soon, maybe we start later, hopefully soon, reverse engineer the Power VR graphic, because this still triggers me. And this is even with hardware solution, right? I booted the original image and change routed here into that T2 build. So this is the hardware isolated graphics that you get from Power VR, and yeah, 100% load and quite some memory, and you get the idea. So also, it's not even the right resolution. I mean, it's resize the window, but yeah, maybe there were some updates. But yeah, so this is the image that came with it in some 5 years ago. So this is hardware isolated, highest performance. Anyway, and here probably, yeah. So also we get here actually some uncaught exception, something no slot size. So yeah, also on MIPS little-endian, also for me that our T2, of course, previous videos we always fix some small details here, and there also the colors get slightly really strange though. Maybe some white balance, maybe the wall shouldn't be yellow. So yeah, change rooted in here of this sort of change root there, and run this T2 binary. So for me, at least testing, certainly, yeah, I could use it as an IoT temperature probe thing here on the wall or something, but otherwise, at least testing T2 that MIPS somewhat works. For the Octane, we still can't be sure what exactly is going wrong there. We certainly would need to fully debug this. Could be simple Octane there, obviously, of that fun stuff. It could be anything, could be big endian, although it works somewhat on the G5. I have the backtrace from, so maybe we shut this down here, shut down. Hello, probably how much memory did this thing actually? It has a gig memory, so it's not that bad though. Shut down H0, and yeah, this was the original image that we changed just for the kernel and driver, because I'm not building a kernel and hardware isolated Power VR stuff for each and everything. What did I wanted to say? I wanted to say, all right, I posted the Spark 64, on which video was that? The backtrace, even loading the backtrace on the dual, probably it was this one, read more. And so even loading the debug symbols on the 4 GB Sunblade 1000 with dual 1.2 GHz, Ultra Spark CPUs took, I think, about 5 minutes. I was already thinking that maybe the GDB is cross-compiled broken. But yeah, this is a backtrace of crashing this on Spark. I've not yet loaded the backtrace on MIPS. Maybe I need to plug out more memory. I wonder, do I have in the spare system board some memory? Maybe not. Maybe I should scrape all the memory from the second Octane. Not sure if I have some slots free and maybe have more than 1 gig memory. But then even maybe massive swap. Did I think? Yeah, I'm not sure. Or I should try to configure a cross-debuggable cross-debugger of doing this on the Ryzen just to load the backtrace, because I wonder whether the MIPS32 backtrace looks exactly the same. And yeah, this is here some IPC protocol, so this could also be bit size of, yeah, whatever, maybe it could be so many things of compiler broken, compiler miscompiling. Not sure if there's already Rust and Cargo stuff in there, maybe not. And then could also be this Rust stuff of LLVM differently broken than GCC. And yeah, as I said in the previous videos, this monstrous projects of the more stuff you plug that together, the more stuff actually needs to work. And if there is one small little pearl in this chain that breaks, then this was all your precious browser. But yeah, at least some stuff works, and we can move on with more interesting stuff like RISC-V and other stuff. And we in general have Firefox cross-compiling, which certainly is amazing, which, yeah, 20 minutes. And why did we do all these efforts? Epic thread-ripping AMD Ryzen builds this Firefox in only 20 minutes with all the latest Cargo and Rust and C++ and slow GCC and LVM and so on. And yeah, imagine do this on a native MIPS32 revision, whatever, 9-stage pipeline at 1.2 gigahertz. It's like, yeah, probably it will compile a year, and why we want to cross-compile this and not like others on Twitter pointing us to web cloud services of Amazon stuff. It's like, yeah, we rather cross-compile our own than we have it for all architectures, and the remaining bugs we probably find someday sooner than between now and forever. Anyway, hope you enjoy this update. I think this is all for this. Also, pipeline-wise, 8-stage 2-way superscalar it's not really that much more we learn here. But could also be cache and memory, if, throughput and stuff, and yeah, 25% more efficient cache here and 25% more efficient, or even 50% more efficient memory there, and at the end it's already plus some 30% more efficient cores or something, and two-way superscalar, who knows what the other thing is there. So yeah, at the end maybe twice as fast or something. But I anyway continue testing with ARM64 because future and T2 and testing, and as seen here live on this channel, what is not tested is broken, just like, yeah. Also, I imported even more patches. As you see, so much stuff in between the videos and work and just parallel multitasking. I rebuilt this for the G5 with even more big-endian patches. It still means, I think the big-endian patches fix, like from Sun, no, allegedly Oracle or something, Solaris for Spark. They fix the menu of Firefox a tiny little bit, like here that, but not fully. Like I think the tabs were still not fixed, and stuff with transparency, like also not Twitter down. Like here even our own website that surprisingly uses here transparency, even that is still broken. So from what I can see, this Sun Solaris patch is significantly not all that is needed, and certainly, in my opinion, really ridiculous that Chromium-based Google's gear stuff used in Firefox is in 2020 not fully big-endian aware, and still has all this big-endianness integration hiccup all over the place. But anyway, that's for this update. I hope you enjoyed this and learned something. This is even switched off. So then I can move on with more interesting stuff, and I hope to see you soon for all the next videos and live streams to come. And as always, you can, looking forward to your comments here or there or Discord.